Okay, so welcome back. And so in this video we're going to do some examples of sequences, seeing if they converge by using the monotone convergence theorem. So first thing we're going to do is let's see what happens when we write out the first few terms. So if we write out the first few terms, so when n is equal to 1, we get what? We get 4, right? When n equals 2, what do we get? Well, we get 4 squared, which is 16, over 2, which is 8, so we get 8. Okay. And then, what about 3? Well, 3 we get, what? 4 cubed, which is 64. And divided by, so 64 divided by 6, divided by 6, and so that's going to give us 32 thirds, right? So that's going to give us 32 thirds. Okay, and then the next one, when n equals 4, we get 512. Oops. So we get 512 over 24. But this also reduces to 32 thirds. Oops. Okay. And then the next one, when we put 5, we get 128 over 15. Okay. Now, if you put this in your calculator, so so 32 thirds is bigger than 8, right? So this is a little bit over. This is over 8, okay? Because 32 divided by 4 is 8, so we know that this is going to be bigger than 8. And then this is the same, and then it starts to go down. Okay, so it goes up, and then it starts to go down. Excuse me. So that's the first thing you want to notice. So this is n. 1, 2, 3, 4, 5. So at n equals 3, it starts to decrease. Okay, so now also we can see this by looking at defining this recursively, right? So if we can define this recursively, then we can show that this is going to start decreasing for n greater than or equal to 3. So we can do n, excuse me, a of n plus 1 is going to be 4 to the n plus 1 over n plus 1 factorial. Well, this is going to be equal to what? It's going to be 4 times 4 to the n over n plus 1 times n factorial. Okay? Which, by the way, is right here, so we see that 4 over n plus 1 times 4 to the nth over n factorial. Well, that's just a sub n, right? So that's going to be 4 over n plus 1 times a sub n. So we can define it recursively, and we can see that this is bigger than 1 up until you get to 3. And then at 3 and going on, it starts to decrease. Okay, so now, so we know it's decreasing for all n greater than or equal to 3. Okay, so this is decreasing function, so not decreasing function, but a decreasing sequence. So 4 to the nth over n factorial decreases for all n greater than or equal to 3. Okay? Okay. So now what? Also, we can see that this is bounded below by 0, right? Because as this gets larger, right? This, as n gets larger, this is going to 0, so you're going to get 0 times a sub n. Okay? And so it's bounded below by 0. And the reason why is because if you see this, well, let me see here. Because this here is bounded below by 0 for all n, all positive values of n. And again, so as you can see here, it goes up, right? And then it goes down. So, and it's going to get smaller. So again, from what we talked about here, this is decreasing for all values of n. So the smallest it's going to go, because this is going to 0. So the smallest it can be is 0. So it's bounded below by 0. So that's another thing we note. Okay, now, because of these two things, we can use the monotone convergence theorem, right? Because we've got a decreasing function, right? Decreases for all values for n greater than or equal to 0. And it's bounded below by 0 for all positive values of n. Therefore, by the monotone convergence theorem, oops. Oops. So by the monotone convergence theorem, we know that the sequence 4n, 4 to the nth power divided by n factorial, converges. Now, the next part is finding the limit. So in order to find the limit, we're going to use the fact that it converges to a number. Okay? So, well, the next step is going to be, now that we've shown that it converges, is to use that fact, and we know that the limit as n approaches infinity of the sequence it must equal some real number L, right? Okay. Now, let's replace this with a sub n, since okay. So now what we're going to do is we're going to use some information that we got from working out the problem earlier. Okay. So now, here's what we're going to do. Let's consider another limit. Let's consider the limit of a sub n plus 1. Okay? Now this limit is also going to have a limit of L. Why is that? Because the only difference between the two sequences of a sub n and a sub n plus 1, right, is one term, right? So if I have the sequence a of n plus 1, right, the only difference between this sequence and that sequence is that I'm not including the initial number, right? That's the only difference. And so a finite sequence a finite number of terms does not affect the convergence of a sequence. So if you can, like we saw before in an earlier video, that when we added, if you had extra terms to the back end or the front end, well, I mean on the left side, so in the beginning, if you started adding terms, it doesn't affect the limit, right? Remember that? Well, if you subtract a finite number of terms from the front end of the at the beginning of the sequence, that's not going to affect the limit either. Okay, so it makes sense that these limits are both going to be the same. Okay. Now, let's combine this with the fact that a sub n plus 1 is equal to 4 over n plus 1 times a sub n. Okay? And so then, what do we get? Well, this limit, oh, hold on. Yeah, this limit here then, right? So if I have this, then the limit of this should be sorry about that. So the limit of this, again, if I take the limit of both sides here, I get this limit has to equal the limit as n approaches infinity of what? This. Right? That makes sense. And so, we conclude what? Well, equal L? Well, what do we get? This has to equal L. Well, what's this limit in here? Well, this is, how do I want to write this? So let's take this for a minute and just bring it out here. So this here is for, oh, hold on. Yeah. So this is going to be the limit of n as n approaches infinity of what? 4 over n plus 1, right? Times the limit as n approaches infinity of a sub n, right? So I'm just using limit laws. Well, what's the limit of this thing? 0. What's the limit of this? Well, it's L. So guess what? The limit is 0, right? If this limit is L and it's equal to this limit, which is equal to L, right? Because it's just, these are the same, right? Then guess what? Oh, sorry. This should be 0. I miswrote it. So we know this, and so we were told that the limits are going to be the same, which is equal to L, right? But this is equal to this limit, which is equal to 0 times L, which is 0. So guess what? L is equal to 0. And so that's the limit. Have a great day.